For the first time ever, astronomers might have witnessed a star actually become a black hole right before our eyes, or telescopes. In this visible light image from the Hubble Space Telescope, we can see a large star about 25 times the mass of our Sun, around 22 million light-years away in the galaxy NGC 6946. This was in 2007. But in a Hubble image from 2015, looking with the same filters at the same wavelengths, the star appears to be gone. I'm Katrina Jackson from NASA's Goddard Space Flight Center, and I'm here today at the Kennedy Space Center to watch the launch of our newest planetary science mission, OSIRIS-REx.
Oh my gosh!
7-year mission to boldly go to the asteroid Bennu and back.
The rocket just you could see it lifting off and all the smoke, and then a couple seconds later, then you could hear the sound just roll in towards you, and it got louder and louder. It was awesome.
It's so bright. The brightness just gets me. I'm there's no other white light like that. And when that bass comes to, that sound rushes up. Oh my God! It was just, I want to cry. It was just magical.
Hello, I'm Katrina Jackson, and I'm here today at our open house event, Explore NASA Goddard. What is your favorite thing about space?
The rocket ships, the Milky Way.
What is one thing that you hope the visitors take away from today?
That we as a species live in space, and that studying space as a way of connecting to our lives is really important. And whether it be Earth or the way the sun affects us or even extending ourselves to Mars, it's all in our DNA.
If you're just now joining us, we are live from NASA's Goddard Space Flight Center in Greenbelt, Maryland. I'm Katrina Jackson. I'm joined by scientists Michelle Thaler and Noah Petro, and we are talking about tomorrow morning's super blue blood moon. We're going to answer questions in a little bit. You can leave them in the comments of Facebook, or on Twitter you can use the hashtag AskNASA. If we don't get to your question during the broadcast, don't worry, we'll be going through the comments afterwards and answering some of your questions there, so just keep them coming. In the meantime, I have a question for you, Michelle. So I know NASA will be celebrating its 60th anniversary of its formation later this year. Next year will be the 50th anniversary of Apollo 11 when the first humans walked on the moon. So we have been interested in the moon for a really long time. What is there that's left to learn and to explore on the moon, and what do you hope to see in the coming decades? For the first time, astronomers have strong evidence for a galaxy not having a significant amount of dark matter. Decades of research have led astronomers to the extraordinary conclusion that 85% of the mass in our universe is invisible in all wavelengths of radiation, and that it's composed of matter that does not contain protons or neutrons or any type of particle we've detected before, and that this invisible material is all around us, passing through us without interacting with regular matter except by gravity. All of the people involved with NASA's Cassini spacecraft are preparing for Cassini's final plunge into the planet Saturn on September 15th. One small portion of the people who have spent years working on Cassini includes the team behind the OSIRIS instrument, the Composite Infrared Spectrometer. OSIRIS was built right here at the Goddard Space Flight Center and has been massively successful in operating without a single command error in 13 years and delivering groundbreaking thermal and compositional data of Saturn and its moons. Personally, I think that the people behind the scenes in the trenches operating the instrument are just as interesting as the scientific discoveries they've enabled.
How would you describe the OSIRIS team and your group of people?
In what terms? glowing terms.
For you, what will that moment be like when Cassini ends?
Sad.
Yeah.
The observations were combined with data from multiple ground-based observatories, which showed Oumuamua to have a small, continuous, non-gravitational acceleration. Something besides just the gravity from the sun and planets was affecting the trajectory of Oumuamua. A probable source of this acceleration is jets of gas coming off the object. Well, the hard work is about to pay off. The 4 MMS spacecraft are set to launch in March of 2015. Thanks to the incredible talents and collaboration of scientists and engineers here at Goddard and across the globe, we're finally on our way to solving this physics mystery and uncovering the dynamics of magnetic reconnection. These dark vortices in Neptune present atmospheric scientists with an amazing opportunity to learn about how storms work on a different world. But because there is so much in the universe that Hubble looks at, the telescope had only been observing Neptune once every few years, which wasn't frequent enough to watch the formation or demise of any one particular storm. Since 2014, however, Hubble has begun a project called the Outer Planet Atmospheres Legacy Program, or OPAL, to gather global maps of our gas giant planets every year for the remainder of Hubble's operation. Now, for the first time, using data from OPAL and additional Hubble observations, Hubble has captured time-lapse images showing the gradual death of a storm on Neptune. Hello, space fans. I'm Katrina Jackson with the Office of Communications at NASA's Goddard Space Flight Center. Now it's August of 2018, and OSIRIS-REx is finally approaching its target, asteroid Bennu. So I found a couple people who can explain what the spacecraft is doing during this approach phase and why it's so exciting to get to this point in the mission. What is the approach phase of the OSIRIS-REx mission?
The approach phase is when we reach about 2 million kilometers from the asteroid Bennu.
What do you think would be the craziest shape you could imagine the asteroid being?
So right now it's fairly a benign shape. It's kind of bulged in the center, but if you look at pictures of 67P Churyumov-Gerasimenko, the comet, where it's kind of a rubber duck, I don't think it's going to be that extreme, but you never know.
Hubble measured the light coming from the star over a period of 40 hours. About 7 hours into the observation, the planet started its transit, which was about an hour earlier than predicted. A tantalizing piece of evidence that the planet has a large moon, because a moon would cause the planet to wobble in its orbit. Hubble's Space Telescope Imaging Spectrograph, or STIS, has capabilities like searching for black holes and looking at the atmospheres of planets orbiting other stars. After STIS had a power failure in 2004, the Hubble team was tasked with replacing STIS's damaged electronics boards on the final servicing mission in 2009, which would turn out to be a memorable day for everyone involved.
And within minutes, Bill Mitchell comes busting through the door, carrying the handrail, still in his bunny suit and his cleanroom garment. We get the handrail all set up, everything's ready to go. We text a couple pictures back and forth. James gives us the green light. And Gene stands up on the table and starts pulling the handrail. And right when he got to 60 pounds, it snapped. Actually, the bolt went flying.
Once we'd done that test, then I got on our communication loops and called it to Jim Corbo.
So ultimately, James came back and said, it'll take about 60 pounds of force for them to break it off.
So Goddard had done this test, fed the information to us. We talked to the flight director about it to get him comfortable.
Okay, Mass, you copy that. 60 pounds linear at the top of the handrail to bust off that bottom bolt. I think you've got that in you.
I can try. I knew I could do that.
What if he pulls it off and there's debris? What if he pulls off the handrail and there's a sharp edge? What if it takes a lot of force and it comes back and hits him?
A whole bunch of new interns are here, which means summer has arrived at NASA's Goddard Space Flight Center. We're excited to welcome over 400 interns from across the U.S. studying Earth science, planetary science, astrophysics, heliophysics, and a multitude of other things. Just think. You are looking at the light emitted 8 billion years ago from gas orbiting a 1 billion solar mass black hole that is flying through its galaxy because it was shot off like a rocket from the gravitational waves produced by the merging of 2 supermassive black holes. And if that's not cool, I don't know what is.